I think I'm loud and clear. And thanks all for joining. And we scheduled a session today, and we can see a lot of attendees already have joined in, almost 10. So we'll wait for a couple of minutes, and we'll start the session. So let's see another couple of minutes how many attendees join, and then we will. Okay, so let people keep joining, and let's start with today's session. So hello everyone, and welcome to today's session. And as you can see, today's session is on artificial intelligence and machine learning, and it is powered by Agile Cloud Solutions. We are partners with Redington, district partner with Redington and Microsoft Cloud. So this session is basically based on how artificial intelligence, machine learning can be used in the business. Doesn't matter how big or small the business is. And we will see going forward what other things we can do with machine learning, artificial intelligence. What is the difference between artificial intelligence and machine learning? How we have seen machine learning, because machine learning is quite an old concept, and we will see how it been propagated years, and then we will move ahead with the demo session. So I'll clear with the agenda. So let's move on to the next slide. So hello all, my name is Vishal, and I'm associated with Agile Cloud Solutions, which is partnered with Microsoft Cloud and district partner with Redington. And I take care of artificial intelligence, machine learning, as well as big data analytics. And you can all reach out to me at vishal@agilecloudsolutions.ae. Moving forward. Okay. So let's start with the very, very basic definition of machine learning. And we will go back to 1959, where Arthur Samuel said, field of study that gives computers the ability to learn without being explicitly programmed. So you can see the last three words, being explicitly programmed, which is really, really a game changer. Why we are saying that this is not being explicitly programmed? We will see going forward. What is the meaning of being explicitly programmed? Because we have seen every computer application is being programmed, but why is Arthur saying without being explicitly programmed? So we will go into the next slide and see what he means by this. Okay, before moving on, let's see how, because in the initial, when we started, I said there is not a new technology. It's been very old technology, but we have started learning more and more about it in the recent years. So artificial intelligence is not new, okay? And we have seen from 1950s and 60s and 70s how we have moved from AI, then machine learning and deep learning. And all you can see is the superset, the top level we have AI, which is techniques which enables computer to mimic human behavior. Now, human behavior could be anything, be it learning how to walk, how to drive, learning how to ride a bike, speaking to somebody, using the analytical skills to design or solve a particular problem. So that's a very vast area. Moving ahead, machine learning, which is basically how we can allow the machines, because from 80 onwards we had a huge change in the computers, and we started seeing IBMs and Microsofts playing, and the big companies, big giants coming into the play and making computer more and more robust and user-friendly. So then it starts with machine learning, which is the techniques that give computers the ability to learn without being explicitly programmed. And you can relate this to my earlier slide where I said the same thing, the ability to learn without being explicitly programmed. So we are not programmed. The human beings are not programmed. We learn. When we started walking or when we started driving, we might have hit a car, we have done something wrong with the acceleration and the brake, but we learn. Same way, the machine learns from its mistakes, and that's something which human beings do. And then we can see from 2010 onwards that there is a huge chunk of companies investing in deep learning. And what is deep learning is basically the neural, and then the remake of the brain, the human brain, how the brain functions. The same thing can be achieved with computers. And we'll see how, not exactly in deep as deep learning, but yes, we will try to understand what it is. Now, basically, a lot of people think of like machine learning versus traditional programming. Why I'm saying this traditional programming? Because when we say that we have written code in machine learning or for machine learning, it's not that we write some code. It's actually the machine who writes the code. And that must be very intimidating, because how can a machine write a code? By what? But there is a huge mathematics involved. However, let's see the difference between traditional programming. At the top, you can see that we have a data and we have certain defined rules. For example, from any of the programming language, we write some if-else conditions, some while loops, we create some objects, we create classes, we instantiate objects, and then we do something on the data, and then we make some decision. For example, if we have to provide a loan to a particular person, we would have certain rules that he must have. Or for example, we want to sell a car, then we want to know that whether the person has the particular salary limit, and then we will see where he works, and then based on that we will either provide him the loan for the car, or we'll say no, we cannot provide you the loan for the car based on certain rules. But in machine learning, it's completely different. What we see over here is it's a little bit longer because we have some historic data. We play on some historic data. Based on that historic data, we see what were the historic outcomes. So now you can see how machine learning is actually mimicking the brain. So for example, we give a loan to a person and he doesn't repay me back. So I learn that, okay, this particular class of people will not return me the loan. So let's learn from it. Same way machine learns based on the historic data. Then they have the historic outcome of the data. And then the machine starts building some rules. So in the middle, you can see automatically inferred rules. What is that? Those are the rules which in the traditional programming, the programmers write codes, manually defined rules, here automatically inferred. So you can see those are defined, these are inferred. And then on top of that, we have the new set of data, and then we make a decision. So ultimately the decision is the end result for both in traditional programming and machine learning. Why it is better? Because the machine has learned. For example, if you have to change a loan giving criteria, you need to add some new rules. But in machine, you don't have to add any new rule. All you need to do is put the same data from the decision back to historic and let machine learn on its own. So this thing will be clear when I move into the next slide and so forth. Now let's see how artificial intelligence has been designed. What are the branches of artificial intelligence? First of all, the first basic thing is machine learning, which is, I can say, is like the superset of all the artificial intelligence branches, but still we have certain mathematical, statistical, machine learning inferences, which comes as a part of machine learning. Then we have neural networks, where we can use deep learning for image processing, for computer vision, as well as also for advanced processings in statistical forms. Then we have robotics, robotic process automations. Then we have natural language processing, where we have already been using Siri, Alexa, where we have we just instruct them and they do accordingly. There's a very beautiful branch called reinforcement learning, and I will slightly touch on reinforcement learning. However, it is a very heavy mathematical branch of machine learning, but still, and image processing. And I will showcase you one example in my next coming forward slides, where one company has used beautifully image processing and reinforcement learning. Maybe you have already guessed it, but let me go back. Let's move into the next slide, and this machine learning and business. Now let's come into the actual area. So where machine learning can be used in business. I'm not here deciding and putting anything on the size of the business. Business could be anything: a big business, a small business, a very small business. But everywhere we can use machine learning because we have data. Every business runs with the data. Transactions, stocks, inventories, and many other things. So be it a big business or small business, machine learning can be implemented everywhere. So these are the few examples, like forecasting in sales, inventory, supply chains, where a company has to forecast its sales, and also perhaps they have to buy something and put it in inventory, and they don't want to put a lot of load in the warehouse, and the supply chain management, of course. Continuous improvement in predicting customer behavior. This is, I can just give you a very relatable example with this, where we see Amazon. So the moment we go into Amazon to buy something, we get a lot of predictions and a lot of recommendations below the website, which shows us similar people have bought these things. For example, if I buy a phone, it gives me a recommendation of a headphone, or a screen guard, or a cover. Same way, if we ever open YouTube and try to see some of the videos, we get relatable and recommendations, which is exactly the same topic. How the YouTube knew that I was interested. For example, if I go and watch CNN, it gives me maybe some other news channels recommendation and some news stories. How is that achieved? Is basically predicting the customer's behavior and giving right recommendations. Automation of tasks with autonomous computers. So we already seen a lot of places where in the factories and big machines where the machines have replaced human beings, and those are basically used in the assembly line. So those are autonomous computers. Real-time anomaly detection. And this is really something which a lot of financial institutes care, because they want to detect anomalies in the customer's transactions and want to do it in real time. They do not want, like, the customer, a person who has a fake account, goes in, logs in, withdraws the money, and then on the next day they will get the bank or the financial institute will get to know whether there was an anomaly, whether there was a fraud. Then the next one is portfolio risk-based analysis. And this is, again, how much a financial institute should invest in which particular business and with which particular management. So portfolio risk-based analysis covers that part. Financial rules and models, which is something of the similar kind, where we have financial rules implied by financial institutes based on the earlier studies. And better customer segmentation and accurate lifetime value predictions. So it's again the customer segmentations, which people, how can we segment the customers with their same likelihood? Okay, so we'll move into the next slide, and you will also understand what I have been saying in this machine learning in business slide. Okay, so as I said, Tesla self-driving car, where in the two previous slides, I told you where I will be giving you an example of reinforcement learning with computer vision. And this is the example where Tesla, they have made autonomous car. This is basically a Model Y car. And how they perform this. So you can see this person is not holding this steer, and nowhere his legs can be seen on the brakes or the accelerator. But still the car knows how to do what. And this is a part of reinforcement learning. So reinforcement learning is basically you give the program no historical data. So earlier when I mentioned that we have some historical data and we learn from the history, this kind of learning is a little different. It does not learn from history. Rather, this reinforcement learning mechanism, it makes a history. It makes a set of history where it keeps trying, like a baby. Like the baby, when the baby is born and when he starts walking, he doesn't know how to walk. All he does is he keeps trying and keeps trying until one day he starts walking. The same reinforcement learning mechanism is used here with a very, very highly developed statistical models. It includes a lot of mathematics in it. But we'll see that we do not have to indulge in a lot of mathematics and programming using reinforcement learning. And then they also use 8-side view LiDAR cameras for computer vision. And there is a completely different branch of computer vision in AI, which deals with image recognition and so forth. Let's move forward. American Express recently said that they have crossed 1 trillion transactions. So it's not the amount, it's the number of transactions. The amount could be, one transaction could be of millions. So American Express has 1 trillion transactions. And how will they detect anomalies? And how will they detect the frauds? So they use machine learning. Obviously, they use machine learning. So over here, you can see the rule-based, it's showing green, where the rule-based algorithms might not be able to perform beautifully on anomaly detection. However, using machine learning algorithms for real-time anomaly detection, it can be used, and American Express uses it. And I have just mentioned one such thing where they analyze income versus spending. They know how much people they have the income and how much they have been spending in the past, and then they do a little bit of averaging on the spending. And if the average of the spending, if the spending goes beyond the 2 standard deviations of the spending, it tries to block it. And you can see over here in the small image, like we have historical data, they build the model. And then from the live data, this model starts detecting. And then it generates either alert or it goes into the application. Staples, now their business is basically for office supplies. So you can see from American Express to Tesla to Staples, where they are providing office supplies, but they use natural language processing for the customer feedback. And they try to segregate the customer feedback. They know which language the customer uses and can be segregated, can be put into the customer's unhappy segregation or cluster, and versus customer happy segmentation or the cluster. This reduces the response time drastically, because now if your business is growing and you have a lot of presence in the social media, you need to have a lot of people who can go through the Facebooks and Twitters and on hashtags and try to do a lot of data mining and manually a lot of data mining, and then segregate the users into different categories. Like this customer is very happy, this customer is bad, this customer is not very happy. So we have to serve those customers who are not happy so that we can have a very good retention policy. So we have lots of algorithms and a lot of machine learning programs which can be used for customer feedback, because they use this Twitter not for advertisement. Mostly we want to show our presence as an advertisement to Facebook page and Twitter page, but no, Staple does that. Instead, they use it for customer feedback. And this because you do not have to then deploy a lot of call center agents to get the customer feedback. All they can do is just hashtag, do it, and then within 5 minutes, they will get a call from Staples or from any of the organization. Wallet Investor. Now, Wallet Investor is an organization, is not a big organization, but a very small, which uses the LSTM, which is a part of a neural network, long short-term memory. They use this neural network for forecasting model. They know which stock will go up and down, and accordingly, they advise their investors to invest in particular stock. And they also control the price fluctuation. For example, there is a kind of a bad news for a particular stock, and they already anticipated that the stock will crash. Then in that case, they already can publish good results, good news to the investors who can actually be little skeptical about investing or withdrawing the stocks. So that's how Wallet Investors uses LSTM. And here is the machine learning pipeline. So what is the machine learning pipeline? So we have done it in development environment. What has to be done in the production environment? So you can see the first step is getting the data. Second is cleaning and preparing and manipulating the data. I will show you actually in one of the demo, what do you mean by cleaning, preparing, and manipulating data? Because lots of data, for example, from Facebook, and we have a presence in UAE. A lot of people writes in Arabic. A lot of people might write in English. A lot of people might just spam it. So how could we clean the data? Or for example, in your front-end application, there was a person sitting and inputting the data in the front-end application. He somehow forgot one field, and that comes as null in the backend database. How can we clean it, and what are the mechanisms of cleaning it? We'll see that. Then we train the data on the cleaned, prepared data, and we train the model with sets of different machine learning algorithms. We test the data on the testing data set, which is the section 4, and then we keep on improving. Once we go live, we keep improving the accuracy of the model. So this is basically the machine learning pipeline, which can be deployed anywhere in your websites, or if you go for a batch processing of hundreds and thousands of data, you can do that. Moving forward, now let's see how we can do this machine learning on Azure. Now, as you can see the particular slide where we have all the frameworks of machine learning on Azure. Now, Azure is a Microsoft product, and as Microsoft believes in making more democracy in machine learning, so that the machine learning, artificial intelligence should not be only concentrated on people who know good programming or who are with masters and PhDs. It makes available to everyone, even a manager or a person with maybe just 2 or 3 employees. He can also use machine learning on Azure, and I will show you how simple it is in one of the demo, where a normal person can actually implement a number of algorithms and see the outcome. So we have over here sophisticated pre-trained model. We have already kept a lot of pre-trained model on Azure, and you can go and explore. So we have for vision, we have for speech, language recognition, and for the search engine optimization. The popular frameworks. So as I said earlier, that Microsoft believes in democracy in all the technologies. Popular frameworks means like we have frameworks called PyTorch, TensorFlow, Keras, and Onyx. PyTorch is basically a Facebook framework. They use PyTorch. Facebook uses PyTorch for, if you remember, we can post an image in Facebook, and the Facebook can determine the faces. So those things are written in PyTorch. Same way, TensorFlow is a Google product. So as you can see, the frameworks, the popular frameworks are all there in Azure. So you don't have to think of all the heavy duty where you have to download TensorFlow, check the difference between 1.1 TensorFlow 1 and TensorFlow 2, and then wait for TensorFlow 3, and then you have to get some performance issues in TensorFlow or Keras or PyTorch. So this all makes you get in one platform. Productive series, where we have Azure Machine Learning. I will be showing you how we use Azure Machine Learning. You can also use VMs. It's up to you where you want to have a new VM and then put all your supplements, all your heavy duty supplements over there in machine learning VMs, and then use your own. And also you can use Azure Databricks. Now Databricks is something which runs on Azure, and this is basically used for big data, for Spark. If you, for example, if you want to process your data using Spark, because Spark also comes along with their own machine learning utilities and their own machine learning, and their own ETL, extract, transform, load. And they have other branches as well for graph processing, likewise. But over here, we will be showing you with Azure Machine Learning, how we can use machine. But obviously, Azure Databricks, you can also get Databricks as easy as you can get Azure Machine Learning. And the infrastructure, because now I will try to explain you why we have CPU and GPU separate, because CPUs are fair enough. It's good that we can do a lot of machine learnings on CPUs, but GPU, which is the graphical process units, they are basically used when you start using PyTorch and TensorFlow, because these are heavy frameworks, very, very heavy frameworks, and need a very compute intensive machines. And then you need to use GPU optimized machines where you can do these things very fast. It will not take like 6 to 7 hours to for a machine learning algorithm to run, but it will be done within maybe 10 minutes. So from 8 hours to 10 minutes is actually done by GPU. And if we use CPU, that will take around 8 hours, 8 to 9 hours, because it's a CPU optimized. And then we have flexible deployment plans where you can go with on-premise, cloud, and edge, and so forth. Moving on, the pipeline is almost similar to what we have. So Azure also gives you a data ingestion. The best part of Azure is like you take one and you can do all. So it's like a one-stop shop for all the things. You can see data storage. You store the data. You do not have to be on a heterogeneous source. You ingest data, you do all your ETLs, you do normalization, transformation, then you do some kind of feature engineering on the data. You train the model, you do some hyperparameter tunings, you test the model, you validate the model, and you deploy the model. And everything can be done on Azure, very easy. And let me tell you one thing. This all thing can be done without any machine learning engineer or data scientist. Even a person with zero knowledge, okay, I repeat, zero knowledge of technical, of R or Python or anything, can actually write codes and do it, because it's all graphical user interface. Remember way back then in 1980s when Microsoft came with a graphical user interface for their operating system. It was so popular and it was so easy. So you do not need to learn a microprocessor language like 8085 or 8086. All you need to do is just use disk operating system. Same way, this is a huge transition and it's a huge game changer by Microsoft. We will be going into some demo sessions where I'll show you how we do a loan approval. This is one model, and the forecasting is the other model. And then after the demo, I will take your questions. So let's move ahead. Okay. So as you can see my screen, we have an Azure platform, and we will be using Azure ML Studio Classic version. And over here, we will see what is the data. So let's start exploring the data first, right? Let's try to visualize the data. So this is Azure ML Studio, where you can have your data, and data can be connected to a lot of other things. As you can see here, I have connected to a CSV file. Let me close it again. This is a CSV file, which you can see from I have kept my loan approval prediction data. And let's try to explore what the data is. So you can see that we have loan ID, gender, married, dependent, education, self-employed, applicant, income, co-applicant, and likewise. And then we have a loan status, which says he should be provided the loan, yes or no. And then property, area, credit history. So if you remember in my slide, I said first is the data, then second thing is cleaning the data. And I told you I'll be showing you how the cleaning of the data is done without writing a single line of code. And then I will also show you how big is the code for this in R, in a programming language R. So people with a background in data science and machine learning might know R is a scripting language. So here we see that if gender is there, you see how easy it is to for graphical graphical user interface. So we see male has more probability, 80%, and female are less, and we have null values. This is the problem, null values. If I feed my machine something which I don't know, how can the machine predict correctly? Okay, and then I see there's a problem in all the field. Married, again we have some null values. Dependents, again we have some null values, and that is the problem. Oh, thankfully in education we do not have any null values. Again we have some null values. Let's see how to handle null values in a graphical user interface. We see cleaning missing data, and these things can be easily found here. Like if you just type clean, you can see clean missing data, and then you can just drag drop anywhere. Okay, so this has already been designed, and then let's see how the cleaning of the missing data is done. So what I do is I launch the column selector. So we have two types of columns. One is numeric, one is non-numeric. Always this is a problem, and we do a lot of machine learning stuff, and you do not have to know all these techniques also, because if you can ask any of the data scientists, they have a lot of trouble doing one-hot encoding, which is basically categorizing the category columns which are either numeric or alphanumeric. I will not go into the details of all those things. I'll just show you how we clean the data. So we launch a column selector over here, so easy. And we see that, okay, we have selected these columns. I'll cross it for a while. And then we have these values. And then easily you can see that cleaning mode is so easy. We can use mode, median, mean, mice. I will not go into mice and all and probabilistic PCAs, but let's use mode over here, which has already been used. And then in the second cleaning missing data, I will be using the loan amount and loan, because remember, when I use this, we have all the alphanumeric data, gender, married, dependent, and this is the numeric loan amount and loan amount. There are two columns in this, loan amount and loan amount term. These are two numeric fields. And again, we replace it with the mode. We have a lot of other options where we can use it from. Then we do a column select on the data. Okay, so basically this is a model. All you can see, this is a model, and I have not even written a single. All these things I can do is like select column data. You just go here. You don't have to write any code. Just write select column data set. This is as simple as it is, which allows you to select what are the columns you want to feed for the model. Because your model, if you see, loan ID is a number which is immaterial of finding out the relation between the outcome and the input. So loan ID is not required. So what I do is select column data. If you can see the launch column selector here, loan ID I've left it, and I have kept all other, because I don't need loan ID to train my model. And then I split my model into test training data set and a test data set, and I use a two-class logistic regression. And this is something, again, a little bit of mathematics, but you don't have to do anything with it. So when I click this, I can get all the parameterization technique. Here you can do all L1 regularization weights, L2, I have kept it for default. You can change it. Basically, lasso and ridge regression, if a person with a background of mathematics can try to hyper parameter tune this part. But if you keep it for default, it takes the best suit for you. And then we train the model. We score the model. After training the model, I just want to show you one very important thing. Remember, I said between a difference between traditional approach and machine learning approach. So here we will see, one second. Here we will see that over there, I told you that we have lots of if-else conditions, lot of while loops, instantiation, and lot of other things. However, in this part, in this kind of Azure machine learning, we do not know all this if-else. What we know is mathematics. If we go by the high school mathematics, all we remember is the straight line equation. If you remember the straight line equation, it was y equal to mx plus c, where m was the gradient, c was the constant term, m is the gradient, means slope, and y was the value, and x was the independent variable. That was there. Based on that, that was a two-dimensional. However, we have other dimensions here. So you see here, the model has already made the weight of that n-dimensional line, which is called logistic regression, which is actually defined by some other formula. But over here, you can see the weights, and it's so simple. It's so graphically, it's so easy to do all these things. You do not have to do anything. And then over here, you see a lot of other features which are actually being done when we do one-hot encoding, which is machine learning engineers' nightmare. So you can see easily one-hot encoding can be done, which I wouldn't emphasize much because I'm not going much into details into mathematics and machine learning programming. And then we finally go into evaluate our model, and let's see what the model has evaluated. And you can see the model is giving me an accuracy of 83.2, like 83% of the time my model has corrected properly. And the AUC is 81.6%, or you can see 0.8. So the more the AUC is, closer to 1, the better. Okay. And then over here, I have made a threshold of 0.5, which you can, change it. And then you have certain values. And then you can easily change the threshold and see your accuracy has decreased. And let's make it 0.5. It has increased. And then if I increase the threshold again, it decreases the accuracy. So the best thing I see is in 0.5. Let's make it 0.5. Yeah, it's fine, no problem. So here you can see that the model AUC curve is like this. Now the same model, if you do not have Azure, for example, if you have no Azure, how can you do that? Let me show you in our studio. This is the program I wrote for the similar objective. Here you can see R, where you have to write lots of codes and hire a person who is very good with R, and then he can write all these things for you. And you can see the AUC is 0.7. Even though the AUC is over there, we found 81.81, it's 0.775 for logistic regression. So I can see that Azure is always a better choice than any of the scripting languages. Obviously, they also have their own scripting languages at the back end. They also run the same algorithms. Logistic regression is being used in both the cases. And you can also use other algorithms like decision forest, multi-class decision forest, multi-decision jungle, two-class boosted decision, two-class decision forest. Over here, we have used two-class logistic regression because we have only two-class yes and no. Now, this is fine, but as an end user, I couldn't understand anything, because as long as I see that working model, I don't understand anything. So there is a very easy deployment method, and this model can be easily deployed here. And then now you can see this place where I will keep my loan ID blank, because remember, we have not given the loan ID any value. We have not selected it. And also loan status we want to predict. And you can see we have already made all these things. So now as an end user, now for me, I have to give a person a loan. So I see a gender male, married is no, dependent 1, and likewise I have made this thing. And let's test the response and let's see what it predicts. It gives me 40. So I should give this person a loan who has these characteristics. You can have a loan approval form, and then he can fill all these things, and then you can decide on 54. Let's try to change something. Let's make it female, and let's see what my this thing predicts. Okay, let's make it female. It doesn't give me a lot of changes. Let it keep as male. And let's try to increase the dependent. Let's make it 2. Let's see how. Okay, let's make it 0 first, that the person is not married and no dependents. Okay, so from 54 it increased to 55. Okay, fine. So probability has increased. Okay, let's say he's not under, he's a graduate. Let's see how the probability changes. 58. Okay, so if he's graduate, you can give him loan because he can repay back you the loan. Let's see, credit history is 1. Let's make it 0. Let's see if he has a very poor credit history, what my model suggests. 0.07, like just 7% probability that he will pay back you your loan. So it says, no, please do not give him the loan. The moment you change the credit history, it changes. And the moment I make it 1, it says, okay, fine, give him with the 58% probability. And then this is the threshold which I was mentioning there, whether I should give him or not. So I kept it for 50%, more than 50, and you can change according to your business model. So let's try to do something else here. Make 24. 58, very good. And dependents, let's make it 3. Maybe 2 first. 60%, okay. It's growing good. Applicant income, for example, loan amount, if I increase by 100,000, let's see. No. So you do not give him 100,000 loan amount, maybe 75,000. So you can see, you can just ask the person, again, it's a no. Okay, 50,000, maybe 5,000. Yeah, it's a good probability, 68%. Wow. So as you can see that it's very easy to be deployed, nothing you need. And if you have been into web development, so you might be aware of the Swagger API. You can use the Swagger APIs and you can embed the code, or you can just consume it in your APIs using this. You have also, if you are okay with C#, Python, or Python 3 or R, so then you get the pro code. You can just use it and paste it in your web page or the server-side scripting, and then this can do it. So here it is, the model where we have predicted whether the person should be provided a loan or not. Let's move into another model, which is a forecasting model. And this, so in this model, let's just go quickly. This is a hotel booking demand. And this data set contains booking information for city, hotel, and resorts. So we have city, hotels, and resorts. And includes information such as when the booking was made, length of stay, number of adults, children, babies, and so forth. And we need to find out the trend of the people coming into the hotel. So how many times my hotel occupancy, my hotel rooms are booked. So I need to make this we have to do a time series analysis and find out which part of the year my bookings are low, how many things are, like how many people at one time can attend, can come, so that I can make my predictions, and accordingly I can either increase the number of staffs or decrease the number of staffs. So let's go. We have again imported. So all you can see, this is a Python code in Jupyter Notebook, but I will not go into the code and everything, but I will show you how the forecasting is done. So this is the data set, and you can see here we have so many number of columns here. And let's do a little bit of exploratory data science, data analysis, where we see that these are all pair plots. So these all, like a hotel is matched with is cancelled, hotel is matched with lead time, hotel is matched with arrival date, same way is cancelled. All the permutations being taken care of over here. Okay, sorry, combinations. And then we do some kind of data exploratory, where we see that resort hotels and city hotels have almost equal weightage. Then we see some transient contract, transient party groups and all. And then we see the cancelled. And here is a very interesting fact that we see as the number of heads increases. For example, if there are people coming as a family, or maybe they are going for a destination wedding, or they are trying to use the community hall or something of the hotel to arrange a meeting, that those are cancelled too high. So definitely there is some problem here. Okay, so let's start exploring. And let me tell you, we will be using a library from Facebook, which is Prophet library, and we'll see how it is done. So we do some kind of data. Remember, we said some data cleansing, data feature engineering, so these things. Here we instantiate the model, and we do this thing. And here we see. So you can see the dots, sorry, ending here. So we have data till here. However, our model predicts this part that, okay, for the next couple of, or maybe 4 or 5 months, your occupancy will go down. So you can reduce the number of staff. You don't have to keep the same number of staffs as you had over here. So then we will start decreasing the number of staff. So this is kind of a forecasting on a time series. So in time, we see what is in time ahead for us. And then we try to zoom this part a little bit, and we see this kind of trend going down in the hotel booking. We see a trend going down, so we do not have to keep so many staff, so we can reduce it because the occupancy is going low. All my rooms are getting less blocked. And then this is the trend. We see that initially it has a very good start, but slowly with passing time, the slope was not very good. And then you can see a weekly. So in weekly, you can understand this very clearly that from Sunday, the occupancy is low. Then on Monday, it gets a little higher. Then Tuesday, again, it goes very low. Then Wednesday, Thursday, and Friday. And Friday, you see, because obviously Friday starts with the weekend, we see a lot of people coming and occupying the rooms on Friday. So definitely, we have to take care of Friday, Saturday. And then from Sunday, Monday, we can be like this. And then again, you can see that in the yearly trend, we can see every year we have, starting from January till December, we have this kind of trend. So we know that in month of around April, May, and around this autumn season, we have high occupancy. Definitely this is a cold place. So people do not like to come during January in the cold weather. And this is being done using this. And now we will use a normal statistical model. So that was a Facebook model. This is a statistical model where we do augmented Dickey-Fuller test. Completely, this is statistical model. So we find a unit root, and then we try to predict the same thing. We have got a Serimax model. Serimax stands for, this is AutoArima. Basically, this gives me the best fitted model for my data set. Serimax is seasonal, auto-regressive. I stands for integrated, MA for moving average, and X is for exogenous variable. So I've put it the seasonal, auto-arima, integrated, moving average, exogenous. And I use this model and fit with the same order, 202. You can see this model has already told me to use 202. And when I use 202, I get a model something like this. And this is my actuals, and this is my model predictions, my time series. So you can see this was almost similar. Both my model from Facebook and from Serimax stats model, both shows that decrease the number of staffs because your occupancy will be going down in the further couple of, or 3 or 4 months. So these are the two models. And if you want to know more about the models and everything, you can go to our website, Agile Cloud Solutions, and can see what are the things we offer here. We are partner with Microsoft and district partner Redington. So I have showcased you one time series and one loan approval. So loan approval, basically I showed you how we wrote it in R and in Azure ML, and also in Azure ML we showed you how you can use it as a web service. And in forecasting, we showed you a small hotel occupancy issue and where they wanted to know exactly when will be the occupancy highest and when it will be lowest, so that they can adjust their staffs accordingly. So now I will invite you to, if you have any questions for me, you can post it here, and I'll be happy to answer your questions. All right. Okay, fair enough. So I think I was clear with my the presentation and my demo. If you have any question, anytime you can reach out to me. and reach out to directly to either Redington or Microsoft, and with my on this email directly, and I'll be happy to answer your questions. And if you want a dedicated session for a particular business problem, we can do the same. We can create a same session. We can show you how it can be done on Azure, how easily it can be done on Azure, and what are the benefits we get using in Azure. And likewise, we can compare the outcomes like I did for the AUC curve, where we got a better result on Azure compared to our scripts. And same way we can help in deploying your models and coming up with the problem solutions if you have any specific to the business. So you can reach out to us at vishal@agilecloudsolutions.ae. All right, so I believe there is no questions, but still I would, if you have any question or anything, you can directly reach out to us on this email ID, and also you can contact Redington, Microsoft, and you can reach out to us, and we can help you in giving you a proper plan, or maybe a demo on a specific problem which you have been struggling in your business. And then we can showcase you how easy it will be to implement and how easy it will be to deploy your model and take use of it without writing even a single line of a Python or R or Scala code or C++ code. And you don't even have to hire any data scientist or machine learning engineer or anyone. So that will be very easy for you. So fair enough. Thank you so much. Thanks all for attending the session. I hope this was useful. And let's meet the next time. Thanks.